length of the pendulum, and the string is constant, and if the gravity changes, what will happen to the period? T is for period. This half power means the square root. So if we differentiate this equation, can you differentiate this one? What's the derivative of this? Can you find the derivative of g to the minus half power? Can you hear me? Can you hear me? Can you hear me?
Yes, I
Yes.
can hear you now.
Okay.
Yeah.
So find the derivative of g to the minus half power. This one.
Square root, negative square root of g.
Yeah, negative. Okay, like this. This comes out, and then the exponent. You can subtract one from the original exponent. That means the exponent is minus 1.5. And in terms, if you want to use the square root, this makes so g times the square root g is in the denominator, like this. So we can cancel this number too. And negative sign survives, and then the dg. Yeah, so using this equation, let's say in B, if g increases, that means dg is positive because g increases, the difference is positive. In such case, will t increase or decrease? Uh, when dg is positive, according to the equation, the dt becomes negative because of this negative sign. So when dt is negative, does it mean that t increases or decreases?
Increases.
Actually, it decreases because it's negative. Negative means if dt is negative, t decreases. Uh, so if t is decreases, that means if period decreases, does it mean that the clock pendulum goes faster or slower? The period means, so let's say original period is 10 seconds. So that means it will take 10 seconds to make one cycle. And if t decreases, that means the due period is, for example, 9 seconds. So it will take only 9 seconds to make one cycle. Does it mean that the pendulum swings faster or slower?
So
That's a speed up because it takes less time to make one cycle. When period decreases, that means the pendulum speed up. And then let's go. Yeah, so let's go to C. And if we change the location, let's say the pendulum, the period increases. If dt is increases, that means the the g decreases because the signs are opposite. So dt is 0.001. So let's say 1000, and the clock's length is 100 centimeters. So the square root of L is 10, and G is 980. So if we simplify this, it looks like this. So if we approximate this, yep. So that's about 0.998 uh, minus. About 1 centimeter per second squared decrease. So the new value of G will be about 979 centimeter per second squared. So this actually happens on Earth. This means because the Earth is not perfectly spherical shape, it's a kind of the elliptical shape because of the rotation. So that means the equator is more flattened compared to the polar region. And actually, the gravity depends on the radius of the Earth. I mean, inversely proportional to the radius squared. That means polar region has a higher amount of gravitational acceleration compared to the equator, because equator has a longer radius. So this means if we move the pendulum clock from polar region to equator, these things will happen. The gravity decreases slightly.